Hi everyone, welcome to this tutorial about solving quadratics by factoring. So let's get started. The first example I have here is x squared plus 5x plus 6 equals 0. So we want to solve for x by factoring. Okay, so let's get started. The first thing you have to do when you see a quadratic is you want to see if you can factor out any common terms. So here I have an x, so the coefficient here is just a 1. Here my coefficient is 5, and here it's a 6. So there's really nothing in common I can take out, so I'm just going to continue. Now once you've done that, your first step is going to be to look at this first term here and the last term, okay? And then usually, to make things easier, this is what I do. You can draw a big X, okay? And then you want to take your first term and your last term and multiply them together. So x squared times 6, that's going to give me 6x squared, and that's going to go right at the top. Okay? And then I want to take my middle number, 5x, and put that here. Okay, so now what I want to find two numbers that multiply to give me 6x squared, and either add or subtract to give me 5x. Okay, so what I'm talking about is this method is called splitting the middle term. So I'm going to take this term here, and I'm going to split that into two different terms, so then we can factor them out easily. Now you'll know what I'm talking about in a second. So once you've done this, you want to look at what are the factors of 6. Okay, so my factors of 6, I'm just going to write here. I have 1 and 6, so 1 times 6, 2 times 3, right? So these would be my factors of 6. Now, I have to choose which of these pairs either add or subtract to give me 5x, right? And they have to multiply to give me 6x. Okay, so you have to meet two conditions. They have to multiply to give you the top number, and either add or subtract to give you the bottom number. Now, if you look at the first one, I have 1 and 6. Okay, now because I have an x squared, I automatically assume that I'm going to add an x to each term because I want to multiply two terms with the x to get an x squared and add them to get an x. So the x is assumed. Okay, so let's look at just the constant 6. So in order to, these definitely multiply to 6, positive 6, okay? The positive and negative really matter here. So positive 6, yeah, but how would I get a negative? I need to have 6 minus 1 to get 5. Sorry, not negative, to get to 5. I need to have 6 minus 1. But if I have my terms as 6 and negative 1, then when I multiply them, I get negative 6, right? And that's not what I want. So this is not the pair we're looking for. If I look at the second one here, we have 2 and 3. Well, 3 and 2 definitely multiply to give me positive 6, and if I want to get positive 5, I can add 3 and 2, and that gives me positive 5. So this works, and this is the term we're going to pick. So next, what you want to do is recopy the first term, plus, and then copy the last term, and leave some space in between. So here we're going to put the two different terms that we split the middle term into. So 5x we said becomes 2x and 3x. So 2x plus 3x. Okay, and you just want to check that. So 3 times 2 is 6, and x times x squared. So 2x times 3x gives me 6x squared, and 3x plus 2x gives me 5x. So these are correct, and my terms are 3x and 2x. Okay, so the next thing I want to do to factor this is look at the first two terms separately and then the second two terms separately. In the first two terms, I want to see what can I factor out from the first two terms, which is common. Well, I see an x in both terms, and that's the only thing which is common. So I'm going to take out the x. And when I do that, in this term, I'm left with an x. And in this term, I'm left with the 2. So x times x gives me x squared, and x times 2 gives me 2x. So this is the factored form of these two terms. Plus, and then I want to look at these two terms. Well, here the thing I have in common is a 3, because this is divisible by 3, and so is the 6. So I take out the 3 in common, and then I'm left with x here, plus 3 times 2 is 6, so 2 equals 0. And you may notice that what we have in the parentheses here and here is the same, and that is good. That's what we're going for, because now we can say, well, in all of this, I have an x plus 2 common, so I'm going to take that x plus 2 out, and I'm left with x plus 3, and that gives me 0. So this is the factored form of the quadratic. So if you were asked to factor, then this is where you'd stop. This would be the factored form. But in order to solve for x, we see that there's two terms being multiplied to get to 0. And whenever you see that, this is the null factor theorem, or the zero product rule. So that says when I have two things being multiplied to give me 0, then either one of them must equal 0. So because we know that, I'm going to set both of them equal to 0, because here we don't know which one is equal to 0. So we set both of them to be equal to 0 separately. And then we solve for x. Here I subtract 2 from both sides, and I get x equals -2. And here I subtract 3 from both sides, and I get x equals -3. So the two values, or the two roots, are x is -2 and x is -3. Let's look at another example. What if I have a coefficient in front of the x squared term which is not 1? Okay, we have to follow the same rules. But here, first I want to look at, is there something I can take out in common from all the terms? So I have 2x squared, -9x, and +4. But there's really nothing in common, so I'm just going to leave it as it is. Again, we want to draw our big X. Look at the first term and the last term. Here we have 2x squared and 4. So they multiply to give us 8x squared. And then my middle term is -9. So this is going to be a little more complicated. We have two things multiplying to give us a positive, but either adding or subtracting to give us a negative. Okay, so again, let's look at what are the what values multiply to give us 8. So what are the factors of 8? We have 1 and 8, 2 and 4, right? And that's pretty much it. So I want to look at the first one here. We have 8 and 1. So when they multiply, yeah, they do multiply to +8. But how would I get -9x? So 8 plus 1 will give me +9x. But how do I make it equal to a -9x? Well, if I had -1, then 8 minus 1 would be 7. So that's not going to work. If I have -8, then -8 plus 1 would be -7, so that's not going to work. But what if I had both negatives? So if I had -1 and -8, well, when I subtract them, I get -9. And when I multiply -1 times -8, a negative times a negative gives me a positive, so that will give me +8. So these would be the two factors we choose. Okay? So to go ahead and solve this, what I would do first is just copy the first term and the last term, set them equal to 0, and then now we're going to split the middle term into our factors, which is -x, so -1x or x, and -8x. Okay, so their factors are -x and -8x. Now I want to look at the first two terms and the last two terms. When I take the first two terms, what I have in common here again is the x. In the first term, I'm left with 2x, and in the second term, I'm left with -1, right? Because I want my x times -1 because I want a negative x here. And then in my second two terms, I'm left with, my common factor would be a 4. So if I take my 4 here, then here I have negative 2x, and here I have a positive 1. Right, so that's a bit of a problem here. Things in the parentheses don't match because we have positive 2x minus 1 and negative 2x plus 4. Right, so how would we change this so that this parentheses is equal to that parentheses? Well, we can make what we take out common on the outside. So we can just change the sign of that, right? So if I change to make this negative, then to get positive, I have to have a negative 2x. And to get a negative, I need to have a positive. So when I do that, well, now the things in my parentheses match. So then I can just take those out in common. So I have a negative 2x plus 1, and I'm left with negative x plus 4. And those will be equal to 0. Okay, so here the main idea is you need to make sure that what you have in the parentheses are the same terms. So then you can take those out in common, and then you can solve setting the equation to be 0. Sorry, that's a very dirty 0. Yeah. So now I have negative 2x plus 1 equals 0. And I have negative x plus 4 equals 0. Now, to solve this, I'm just going to subtract 1 from both sides. So negative 2x equals negative 1. And then I have a negative on both sides, so I'm going to divide both sides by negative 1. And when I do that, the negatives cancel out. So 2x will be equal to 1. And x is going to be equal to a half. So if I just divide both sides by 2, my x is going to be a half. Now on this side we have negative x equals negative 4, so subtracting 4 from both sides. And again, because I have negative on both sides, I'm going to divide both by negative 1. When I do that, the negatives cancel out, and I'm left with x equals 4. So my two roots of the equation will be x at positive 1/2 and x at positive 4. Okay, so this is how you would solve quadratics by factoring. Thank you.